everyone, this is lecture 30 of the course on principles of behavioral economics. We concluded the discussion on prospect theory as presented by Kahneman and Tversky in their two papers published in 1979 and 1992 till the previous module. Now, in this module we are going to discuss some of the criticisms that are raised against prospect theory. PT has now been around for over 3 decades. During that time, not surprisingly, considering its non-conventional nature and radical implications, it has attracted numerous criticisms. It is important also to distinguish between PT and CPT, that is prospect theory and cumulative prospect theory, since different criticisms may apply in each case. Some of the criticisms have been theoretical and some empirical. So, in the first case, it has been claimed that the theory contains contradictions, is incomplete or lacks clarification, whereas in the second case, that is in the case of CPT, here first case refers to PT and second case refers to CPT, the claims are that empirical data violates the assumptions of the theory and that the theory makes incorrect predictions. But it should also be noted here that some of the criticisms that are raised against PT are taken care of in CPT. Also, some of the criticisms that are raised against both PT and CPT are observed to be invalid by some other authors. Nevertheless, we list out the criticisms that are pointed out. So, in terms of theory, there are 4 main criticisms here: the lack of normative status, internal contradictions, incompleteness, and the determination of reference points. Empirical criticisms relate to violations of the combination principle, violations of stochastic dominance, the failure to explain the Allais paradoxes, violations of gain loss separability, the nature of the utility function, endowment effects is one such example, the discovered preference hypothesis and misconceptions, and the nature of framing effects. Now, as you can see that some of these criticisms are highlighted, that is because we are going to actually discuss only these criticisms, because some of the other criticisms that are not highlighted are either no more relevant or maybe also the criticisms are contradicted by other authors, and the third possibility is that due to paucity of time and space, I just need to focus on some of the important criticism. So, we begin with internal contradictions. The criticism comes particularly from Birnbaum, who drew attention to the editing rules which he stated as imprecise, contradictory and conflict with the equations of PT. These contradictions mean that PT can explain most empirical results ex post simply by applying the editing rules selectively. So, here ex post implies that once the results are observed, then we can always, by using selective editing rules, can make sure that the empirical observations are explained by our theory. Unfortunately, the downside of this characteristic is that the theory is claimed to be difficult to use for prediction purposes on an ex ante basis. Ex ante basis implies that when things did not happen. So, it is sort of like forecasting. So, it is not able to predict the behavior much, rather the behaviors that are observed it can to some extent by using selective editing rule can predict or explain rather. This has unfortunate consequences also as far as the explanation of the Allais paradoxes is concerned. Now, we will be considering an experiment in order to explain these internal contradictions. So, in this experiment, each gamble is represented by an urn containing 100 marbles that are identical except for their colors. The urn for gamble A contains 1 red and 1 blue marble, each of which pays $100, and it has 98 white marbles that pay nothing. So, this is one important description of gamble A. Urn B, which basically refers to the urn under gamble B, contains 1 red marble paying $100, 2 green marbles that pay $45 and 97 white marbles that pay nothing. Now, the prospects are given as first of all choice 1. In choice 1, you have gamble A and gamble B, you have to choose basically one of them. So, as far the description goes, gamble A can be written as you win $100 with a probability of 0.01 because there is only one red ball. you again win $100 with a probability of 0.01 because there is only one blue ball and there are 98 white balls for which you do not win anything. So, it is basically 0. In a similar fashion, for B there is one red ball which gives you 0.01 or $100 with a probability of 0.01 because one red ball. There are two green balls, each give you $45. Since there are two green balls, the probability is 0.02 and then there are 97 white balls which do not basically give you anything. So, you get 0. Now, applying combination, choice 2 can be obtained as A prime, where I am actually combining the first two prospect, right. So, this is the combination rule. If I combine the first two outcomes of prospect A, then I will be having 0.02 with a probability of 0.02 to win 100 and then 98 to win nothing. B remains as it is. So, this is how we can bring some changes in the, basically some editing is done to the first set of gambles. Now, if I apply cancellation, then choice 3 can be obtained as, where the cancellation is applied to the very first two prospects. Now, you can see that the first two components of A and B are same. So, if they can be ignored altogether because they are common to both of them, this is what cancellation principle implies. If that is done, then there is 0.01 probability of winning 100 and then the rest 99 you win nothing. Similarly, we have 0.02 to win 45 and then there is 98 that you win nothing. So, you can see that first combination and then cancellation is applied. However, choices between 1 and 2, that is choice 1 and choice 2 and the one between 2 and 3 or the one between 1 and 3 need not be the same and may result in preference reversal. So, this is what the internal contradictions in terms of the way prospect theory suggests applications of editing rules, which may itself lead to some internal contradictions or inconsistent preferences. The next one is the failure to explain Allais paradoxes. Different theories explain the Allais paradoxes in different ways. We have already seen that PT was originally constructed in order to explain these paradoxes in terms of editing principles. In order to test the implications of PT, Birnbaum devised some tests which dissected the Allais paradoxes by presenting them in gambles of different forms, some using the combination principle, some using the cancellation principle. Based on the empirical data from 200 participants, Birnbaum concluded that neither OPT, that is the original prospect theory, nor CPT, that is cumulative prospect theory, with or without their editing principles of cancellation and combination can account for the dissection of the Allais paradoxes. So, just the example that we took in the context of internal contradictions, that itself is an example of the fact that the theory failed to explain some of the Allais paradoxes. The next criticism is the determination of reference points. Some economists view it as a weakness of PT that reference points are not determined endogenously. The determination of reference points is necessary in order to estimate the incidence and effects of loss aversion. A good example of this problem relates to the endowment effect. If subjects are given something for free in an experiment, they are likely to value this object differently than if they had earned it in some way. So, basically when we earn something, they are dearer to us as compared to when we get something as a windfall. In later topics also we will come across the differences in terms of our treatment towards monetary gains or any kind of gains, one which is coming to us as a gift, which is as a windfall, and something which we actually earn with lot of effort. So, hard earned money is always valued more as compared to something which comes to us freely, easily, as a gift, as a windfall. Kahneman and Tversky and other supporters of PT generally use either the existing situation as a reference point or some anticipated or expected situation. However, more precision regarding the determination of reference points would be an aid to constructing better models of behavior, in the sense that if we actually pay attention to the reference point, that from where it is coming, is the reference point relate to my hard earned money, or the reference point relates to some sudden gains, then it is quite possible that when the reference points vary, then my attitude towards different uncertain or risky situation would change. For example, it would be useful to know if different types of saver or investor have the same reference points or consideration of dynamic adjustment of reference points over time, like writing off sunk costs and things like that. The next criticism refers to the concept of loss aversion. This is a key component of prospect theory and implies that most decision makers find symmetric bets such as lotteries of the form 0.5x, 0.5 minus x unattractive. This is something we also discussed while discussing the prospect theory, that symmetric bets are actually not much preferred when you win certain amount and lose the same amount with equal probabilities. However, a study by Adam and Kroll in 2012 indicated that a majority of risk averse subjects prefer similar symmetric lotteries to a sure thing. Having established that a sample of say 50 subjects were all risk averse by comparing their certainty equivalence to a lottery of the form 0.5, 50, 0.50, the study then examined willingness to accept a lottery of 0.5 y plus 6, 0.5 y minus 6 in preference to a sure thing of y. So, see, first of all, they established the fact that all the subjects were risk averse by comparing their certainty equivalence with the expected value from a lottery like this, and then it examined the willingness to accept a lottery of 0.5 y plus 6 y plus x, 0.5 y minus x. This is a symmetric bet in preference to a sure thing of y. PT predicts that such subjects would prefer the sure thing because of loss aversion, but 96% of the subjects played at least 1 out of 25 lotteries with an average of 15.9 lotteries played. Adam and Kroll suggested that these results provide evidence in favor of a theory of attraction to chance caused by emotional factors. The next criticism is the nature of utility function. Another criticism relating to the utility function has been raised by Levy and Levy, in short LL, in 2002, arguing that the original KT data did not provide a reliable indicator of the shape of utility functions because it always asked subjects to compare prospects that were both either positive or negative. So, basically to begin with, they were strictly positive or strictly negative prospects. In reality, the LL study claimed most prospects are mixed, involving situations where there is a possibility of either gain or loss, for example, in investing in the stock market. So, when you invest in the stock market, there is always a possibility of making some losses and making some gains. Maybe the probabilities vary, sometimes the winning probabilities are higher compared to losing probabilities, sometimes it is the reverse. Nevertheless, most often these are mixed prospects. The study included a number of experiments asking respondents to choose between such mixed prospects. The main objective was to test whether the data supported the PT model with the S-shaped utility function or the Markowitz model with the reversed S-shaped function throughout most of the range. So, Markowitz utility function also I had earlier in an earlier module, I have just shown that this is not typically the S-shaped utility function as suggested by the prospect theory, rather it has actually some portions where it is convex, some portion it is concave. So, in some way these are inverse, rather these are S-shaped utility function suggested by Markowitz, reversed S-shaped utility function suggested by Markowitz. The study used a total of 260 subjects consisting of business students and faculty from a number of institutions along with a number of professional practitioners. The subjects were asked to consider that they invested $10,000 in stock and were evaluating possible returns, choosing between the following two mixed prospects. In the first, that is prospect F, you lose $3,000 with a probability of 0.5 and there is equal probability of winning $4,500. the other prospect G gives you a probability of 0.25 to lose 6,000 while you win or gain 3,000 with a probability of 0.75. Now, if I compare these two prospects, we see that both prospects are first of all mixed. Their expected values are the same. In both situations, we would be getting an expected value of $750 and the same for both the gains and the loss components. That is 300 multiplied by 0.5 gives us 1500. So, here minus 300, so minus 1500. Similarly, minus 6000 multiplied by 0.25 gives me minus 1500. On the other hand, 440,500 multiplied by 0.5 gives me 2250 and similarly I will be getting 2250 by multiplying 3000 with 0.75, right. So, gain and loss expected values are same, overall expected values are same from the mixed prospects. Now, according to the PT, people are risk averse in the domain of gains, therefore, they should prefer the gain of 3000 with a probability of 0.75 in prospect G to a gain of 4500 with a probability of 0.5 in prospect F. Here the gains are higher, but then here the probabilities are much higher. So, that is why risk averse individuals would be choosing 3000 over 4000. Similarly, the PT model proposes that people are risk seeking in the domain of losses. Thus, they should prefer a loss of 6000 with a smaller probability like 0.25 in prospect G to a loss of 3000 with a higher probability of 0.5 in prospect F. So, combining these two, we see that prospect G is dominant over prospect F. However, Allais found that 71% of their subjects preferred F while only 27% preferred G, which supports the Markowitz model. So, as predicted by, basically the observations did not support prospect theory's predictions. They interpreted this finding as showing strong evidence against the PT model and combined with the results of other tasks in their experiments, they concluded that the Markowitz model was better supported. Next, we have violations of gain loss separability. For mixed prospects, CPT describes valuation of gains and losses separately and then they are added together. This assumes the feature of gain loss separability, that we can always separate gains from losses. In simple terms, this means that if you prefer the good part of B to the good part of A and if you prefer the bad part of B to the bad part of A, then you should prefer B to A. However, various empirical studies have contradicted this feature. For example, Wu and Markle in 2008 reported a reversal between preferences for mixed gamble and the associated gain and loss gambles such that the mixed gamble A is preferred to mixed gamble B, but the gain and loss proportions of B are preferred to the gain and loss proportions of A. So, what it simply tries to say is that B and A both are mixed prospects. So, B has some negative component, some positive component, and similarly A also has some negative component and some positive component. So, it has been observed that the negative component of B is preferred to the negative component of A. In a similar fashion, the positive component of B is preferred to positive component of A, which implies that B should be ideally preferred to A, but then people actually preferred overall A compared to B. So, that is why the gain loss separability might not be valid all the time. So, if you separate gains and losses, they may individually look attractive, but when you combine them together, then a combination or combined prospect may have a completely different preferences or choices. The next one is the nature of framing effects. The inconsistent results have been reported regarding the ability of PT to explain framing effects. Different types of framing effect have been demonstrated as standard risky choice, attribute framing and goal framing. It is claimed that PT probably best explains the first type of effect, that is standard risky choice, but not the other two. It also doubted that PT could interpret the empirical evidence of risky choices in different contexts, or that a framing effect depends on task, content and context variables inherent in the choice problem. In the context of Asian disease problem, which we have already discussed, people are informed about a disease that threatens 600 citizens and asked to choose between two undesirable options. In positive frame, people are given a choice between A, which saves 200 lives with certainty, or B, a 1/3 chance of saving all 600 with a 2/3 chance of saving nobody. So, you can see that as I previously mentioned, this is the positive or the gain frame. Most people preferred A to B here. In the negative frame, people are asked to choose between C, which is 400 people dying with certainty, or D, a 2/3 chance of dying, 600 dying and 1/3 chance of nobody dying. In this case, most people preferred D to C, in spite of the fact that A and C are identical results or prospects and B and D are again identical results or prospects. Several studies have argued that this approach actually confounded two different effects, a framing effect and a reflection effect. So, as also previously we mentioned while discussing the Asian disease problem, that it contains several effects, two of them are framing and reflection. So, these impacts are considered to be confound in the sense that they are together impacting the decision. So, things cannot be particularly ascribed to any particular effect. A framing effect depends on whether the problem is framed in a positive or negative frame, which depends on the negation not. A reflection effect depends on the domain of the problem, meaning whether it relates to a gain or loss. To illustrate this difference, statement A, 200 people will be saved, represents both a positive frame and a positive domain, whereas statement C, 400 people will die, involves both a negative frame and a negative domain. It is therefore argued that because frame and domain correlate perfectly in Tversky and Kahneman treatment of the Asian disease problem, it is impossible to disentangle the framing and reflection effects. On the other hand, it can be claimed that the statement 400 people will not be saved, although identical in meaning with statement A, involves a negative frame but a positive domain. Similarly, the statement 200 people will not die is identical in meaning with statement C, but involves a positive frame with a negative domain. Thus, by restating A and C, it is possible to test PT against other theories as far as explaining framing effects is concerned. So, with this I conclude this module on the criticism of prospect theory, and this also concludes the third topic on prospect theory. Thank you.